Hello everyone, welcome to day 23 of our Competitive Programming Challenge. So as usual, we'll start our timer. We'll be solving or trying to solve questions from CoachF for 1 hour. And let's go to practice. And since we are on 1-star, we'll be solving 2-star beginner level questions. And let's solve questions of binary search. Okay, there are a lot of questions in binary search. What about the data structures? Oh, sorry, I forgot to. Okay, there are quite a lot of questions here in binary search. Yeah, there are no questions here. In dynamic programming, what shall we do right now then? Okay, let's solve questions from arrays from 2-star beginner level. Okay, there are a few questions, that's it. So we'll try to finish these questions. Sorry. Okay, let's create a file using name1.cpp. Okay. So it's an array, right? So we can take our array snippet blindly. Let's see the question right now. In an attempt to reduce the growing population, Archer was asked to come up with a plan. Archer, being an intelligent as he is, came up with the following plan. If n children with name are born to parents with names A and B, and you consider C to be the concatenation of all the names of the children, that is C is sum of all this, where plus is concatenation operator, then C should be a substring of one of the permutation of A plus B. You are given the task to verify whether the names parents propose to give their children are in fact permissible by Archer's plan or not. Okay, first line I will give a T, the number of test cases. Each test case contains two space separated values A and B. So let's take A and B. B. You know the name of the parents. The next line containing a single integer n. So next line will also have n. So let's read n. Single integer n denoting the number of children A and B are planning to have. Following these are n lines. The ith line containing Ci, propose the name for the ith child. Print for each test case output a single line containing yes if the names are permissible by Archer's plan, otherwise print no. Okay. Constraints are 1 LEQT, LEQ100. Okay, sorry. The lengths of all the strings include A, B and C will be in the range 1 to 40,000. Both inclusive, all the strings will contain only lowercase English letters. The combined lengths of all names of children will not exceed the combined length of the name of the parents. Okay. Here Tom Marvel, sorry for mispronouncing the name. So in test case 1, x is equals to the given name, right? And y is equals to Lord Voldemort. Consider z. It is not difficult to see that z is a permutation of x and y is a substring of z. Since y is a substring of a permutation of x, so the answer is yes. Here x is g pop n heap up since y in its is a permutation of x, and as everything is a substring of itself, y is a substring of x and also a permutation of x, hence yes. Okay, this has two space separator strings, right? So I was confused. That's what I was thinking. We are having string a and b, and then we are having int n. So first, for every test, the first they will give number of test cases, then we are reading a and b, then we are reading the number of children they are hoping to have, that is 2. After 2, we need to check if Lord the thing is, I'm thinking is you can search if a letter is present in this children. If that letter is present in the name of parents, then we can form the letter. But we need to also check the frequency, right? So I think it's quite a long algorithm where you will take the string, then you will calculate the permutation of every letter, then you will read the name of children's, then you need to find whether that letter exists in the name of the parents or not, and it should also exist the number of times the number of times also need to be considered. Like in this case, a is used 2 times. Okay, it's not in Voldemort. O is used 2 times. So in Tom, Marvel will need to have O also 2 times. So those are the things we need to consider. Okay, we are not having an array. Let's take a flag equal to 0. Initially we will printing if f, then we'll say yes, else we'll say no. So initially we'll be saying yes, then if something goes wrong we'll say f equal to 0, then we'll be printing no, and here the output should be yes and no in capitals itself. It is case sensitive, right? Yes. So now speaking of the idea to solve this question, that's what I thought for the first case where you'll calculate the calculate the number of times each letter is repeating in a given string. You can do it in that way. Or else, you need to calculate the frequency. After calculating the frequency, okay, let's do in that way. I guess this is permutation of a plus b, right? So after reading all those strings, we'll just do a plus b. We also need to read C, right? We need to read C for each and every letter. How are we gonna do it? Okay, here C is the sum of all the names, right? So let's take a string C and let's initialize it to empty, and let's take a for loop with I equal to 0, I less than n, I plus plus, because there will be n name of the children's. So now taking n children, so it is a string k c in k c plus equal to k. We'll be adding k to the c. Okay, now we'll be doing that, and let's take the array. We'll take array for parents, right? Parent letters, there are 26 letters, so, and initialize all of them to with 0, and let's also take children's. We already use ch for children array, same size is 26, and we'll be initializing it with 0. Okay, now we are having parent array and children array. We need to iterate over it, over the string. So we'll say for how do we iterate over it? We can take I, but we don't need the string values, we just need the frequency, right? So in the array at that position we'll be taking, since all the letters will be small or capital, I guess all the letters will be small, even though it is not mentioned anywhere, I guess. So let's just say for all character, okay, let's take the iterator in this way. We'll say p of that character minus, since the ASCII values will be represented, so we are subtracting 97, and we'll do the same for children also. Okay, we are adding a and b, right? So that's where we use the b. I was just thinking, where did we use the b? Okay, after doing the same, we need to check whether the number of those frequency values, like if the parent array is having 2 A's, and if the next array is having 1 A, let's say 2 A's, 0 B's and 3 C's, it has this way, it is acceptable. There are 2 A's in the parent and the child is using only 1 A, and children is using only 1 A. If it is greater, then we cannot do that way, so we'll say no. So we'll take a for loop, for loop int I equal to 0, I less than, okay, it's not n, I should be the size of p dot length, but we declare it as 26, right? So 26 I plus plus, we'll say if p of, if children array is greater than parents value, we'll say f equal to 0, and we'll break it there, and if it is 0 we'll print no. So let's try compiling it. Name1.cpp. Okay, I just opened the file. G++ name1.cpp. Now let's give our sample test cases. Yeah, we got yes, yes, and no. That was a pretty straightforward question right there. I am saying straightforward because we have done the same thing they asked to do in the question. We took the both A and B, we added them A and B. We took the C values and we have concatenated them. Then we found the frequency of letters. We increased the frequency of letters used here. Yeah, actually it got reset actually. Okay, it's a correct answer. We solved 65 more problems. How many did we solve right now? Oh, that's a quite big number, I guess. ls mc dash l. Okay, it's wc, right? Word count. Yeah, we have solved 50 questions in 23 days. Not bad. That's a quite good number. Next, let's solve chef and walking on the rectangle. Okay. Autumn ch rect.cpp. Okay, chef likes rectangles among all possible rectangles. He loves rectangles that can be drawn like a grid, such that they have n rows and m columns. Grids are common in Byteland, hence chef has drawn such a rectangle and plans on moving around in it. The rows of the rectangle are labeled from 1 to n from top to bottom. The columns of the rectangle are labeled from 1 to m from left to right. Thus, the cell in the top left can be denoted by 1 1. The fifth cell from the left in the fourth row from the top can be denoted by 4 5. The bottom right cell can be denoted as n m. Chef wants to move from the cell in the top left to the cell in the bottom right. In each move, chef may only move one cell right or one cell down. Also, chef is not allowed to move to any cell outside the boundary of the rectangle. Of course, there are many ways for chef to move. Chef has a curious spot. While going from 1 to 1 to n, m, he drops a stone on each of the cell he steps on, except the cells. Chef repeats the game exactly k times. Let us say that he moved from 1, 1 to n, m exactly k times. At the end of the k journeys, let the number of stones in the cell with the maximum number of stones be equal to s. Chef wants to know what is the smallest possible value for s. Okay, in input, the first line contains single entity number of test cases. Each of the next 3 lines contains 3 integers n, n and k. Okay, we have n, m and k, 3 integers. Okay. Let's take our array snippet and let's remove all this. Test cases, then in each test case, 3 integers, right? Int n, n and sorry, you can't type and there. Okay, we took the n, m, k values. For each test case, output the smallest value possible for s if the chef chooses the k paths smartly. Okay, 2 to 1. So 1. If chef selects 2 paths that have a common cell, such as 1, 2, 2, 2, 3, 2, 3, 3. So to make the S minimum, after reading this, it is understood that chef should move in paths which doesn't have common cells. Okay, that is the path he need to take actually. Okay, he should not travel the path he already traveled, right? Here it is given n, m and k are less than or equal to 70. So n rows and m columns. Fifth cell from the left. Okay. Columns are vertical things, rows are the horizontal. So fifth cell from the left and fourth cell from the top. 0, 1, 2, 3, 4, 5. Okay, I guess the indexing starts from here 1, right? So 1, 2, 3, 4, 5. Then the 1, 2, 3, 4. So it in y-axis it is 5 and in x-axis it is 4. That's what it is, 4, 5. Okay. Okay, how can we solve this thing? Should we make a matrix ourselves and then try to travel? Like initialize all the numbers with 0. If we initialize all the numbers with 0 and if we try to travel, we should also remember if it is the path we have traveled or not. Or is there any formula where 2 to 1? How can we solve this? I think there may be some formula in solving it. Like okay, for now let's consider a matrix of one column and one row. So in this case the maximum value will be 0. Okay, let's consider a matrix with one row and two columns. So here the maximum, if he is traveling for k times, so the value will be k only, right? If he wants to go from 1 to the n for 2 times, the same goes with the one column 2 rows. If you travel k times, the value will be k. Okay, we can say that right now. I mean, like first we'll write if, like I'm thinking, can we do this with if else or not? What if there are so many conditions that we need to think of? Okay, let's go for 3 rows. Yeah, let's go for 3 rows and 2 columns. Oh, sorry, 0 0 and 0. If he wants to travel from here to here, then first we will travel in this way. If it is for what, 2 times, next he will travel in the reverse direction, I mean in this way. Okay, we should not increment the starting and the ending, right? It's for 2 times. Since there are 2 ways, we can have 2 or every next time. So every even number, this value will be changed. So if it is 3 times, then the value of this will be changed to 2. If it is 4 times, it will be 2 itself. So I'm thinking for a formula where we will be able to print them. Or where we can solve it in the okay, if we are having more than 3, then there will be 3 or 4 ways, right? Here then he can come in this direction, like from this direction, and next he can travel in row in only first column, and then in the last row. Then he can travel on in the middle. Then he can go for some zigzag way. Wait a minute, even if he goes in zigzag way, there will be some common cells, right? So here the only cells that are not common will be and these other, like, so 1 2 3. If we'll go for one more row, I mean one more column, we'll have one more way of doing it. So we'll be having even number of ways, right? Half of even number of ways. So since we got 3 cases, let's try to have those 3 cases here. We'll say if we have seen n equal to 0. Okay, n equal to 0 is not possible, will only come from 1. So if n equal to 1, or m equal to 1, sorry, m equal to 1, we will be printing. Okay, if there is one row or one column, we'll just printing those things. How many times you want to travel, will be printing those will be the smallest number of stones you can find actually. Let's say else if, let's say n, we have one row, and if it are having 2 columns, or 2 rows and 1 column, we'll print that's it, I guess. Okay, that's one case. I'm trying to recollect what was the second case I was thinking. or I was explaining there. Okay, anyways, let's say else. If else, in else case, we'll take a variable count equal to 0, and there will be half of value of k, right? So less than or equal to k, and our I can't be 0, so we'll start from 1 and we'll increment I by 2 times, and every time we enter this for loop we'll be incrementing the count, or we can just say k by 2. But what if k is alright? So we'll go in this way and we'll print the count also. Let's clear, let's compile. Let's copy this. Okay, we got 1 1 12. Yeah, it is working quite fine. Let's submit it. Currently running test case 3. Yeah, we got wrong answer. What are we missing here? If it is one row or one column, we'll be having k number of times. If it is one row but 2 columns, the maximum value of any cell. But he said wants to know that what is the smallest possible value for s. Okay, if it is smallest possible value, okay, I didn't read this properly actually. Exactly, k time at the end of all the k journeys, let the number of stones in the cell with the maximum number of stones be equal to s. Jeff wants to know what is the smallest possible value for s. Okay, maximum value can be s. He wants to know the smallest possible value also after k journeys. So, okay, then one more case occurs. Here he can avoid one way, right? So that possible value will be let's say else if possible value will be 0, right? So if n equal to 1 and m is less than or equal to 2, or do you have or also? Yeah, or you're having one column and number of rows are less than or equal to 2. In that case we'll just print 0. That could be the possible value, right? That could be the smallest possible value for the in that case. So let's just copy this thing, let's paste here and this is submit. Okay, we still got our wrong answer. So there is something we are missing actually. Okay, we need to first check this case first, right? If m equal to 1, here itself it gets executed, but we need to check this case first because we are checking both the values right there. So let's just change that. Let's just change this to if and let's just have this as else if, and let's submit. Submission is queued. Currently running test case 1. Currently running test case 3. Yeah, we got the correct answer. Okay, that's how we have solved it today. And that's it for today. Let's remove a.out file and let's add all the values, and we'll also commit saying it is day 23. Yeah, all this code will be available in my Git repository that I'll provide the link in the description, or you can also check for the questions in that repository, since we have solved 50 questions in 2-star, so there may be a chance that you can find the answer to the question you are looking for. So thank you everyone.